Hi everyone. I wanted to create a quick video here going over the lab assignment where you had to download census data and then bring it into Arc Pro and define the projection and join the percent 25 and over of educational attainment. So a couple things first. So when you, let me not open that one. So when you download the census data, you got this Excel file, and you had to kind of go through here and figure out which variable was the percent 25 and over. You would have to use the um, metadata that came with it, and it'll tell you which column is associated with the bachelor's degree that you wanted. So once we did that, you would kind of limit it down to 3 columns. And so in GIS, when you're joining Arc Pro, you're going to only want to have one header. So this is row 1, row 2 are called headers. So you would want to delete the row 2 header and format that. And so what you would end up with is an Excel file like this. And a couple things to point out here. One, you'll notice that this data here is aligned to the right, and that means it is a numeric value. This side over here, you'll notice this and this is lined up to the left, and that means it is a string or text. And when you're mapping in ArcGIS Pro, you can only, if you want to make a graduated symbol or a choropleth map, that's a numeric value. You can only do that if the data is numeric. So I could only make a choropleth map showing this data. I could not make a choropleth map of this or this because it is string, so it doesn't make sense. So once you have this formatted, you can, I say save it as an CSV file, but you can also save it as just an Excel file. And down here, you'll notice I named the sheet PCT 25 over BA. So when you go to add it into, if you save it as an Excel file to Pro, it'll ask you what sheet you want to add, and you can just add this. So here we can go back to Pro, and my screen will look a little different Pro than yours. So, and some of the data, I've used 2019 data instead of 2020, just because that's the data I have from before. So if I add this, but it's the same process, you'll notice Idaho looks kind of funny, right? It's squat, it's kind of very wide. So let's check out why. So if we open this up, properties, we go to source, spatial reference, and we can see that the coordinate system is NAD83. And as of now, the Census Department, all their shape files, feature classes, so forth, use NAD83. But you'll also notice that the angular units are in degrees. So that means that the data is not projected. It has a coordinate system, but it's not projected. So we are going to want to project this data so it doesn't look different than what people are expecting to see. So if we go to geoprocessing and we were to type in just project, or did that, we can go to project data management. And so what we want to project is this data. It's going to give you a default setting, make sure where it goes. It also is just going to tag on project, project. So you might want to change that, and you can just go in here, and anything after this is where it's going to go to this geodatabase. You can just change this to something else, tracks, something like that. Now we want to change the coordinate system, right? So if we scroll to here, these are not going to be correct. What we want to do is click on the select coordinate system. And we want to find the Idaho transverse Mercator, and it's a projection. It's a state system. And we can scroll down, and here it is, NAD83, Idaho transverse Mercator. So we can select that and say OK. And then we don't have to fit in. There's no geographic transformation. That should be good to go. And click Run. And there it adds Idaho. But lo and behold, it doesn't look any different. It looks like the same. What's going on? Why is that? Well, let's go check. Properties. We can go to here, General, and we can go to Source, Spatial Reference. The projection is correct, right? We just set it to NAD 83, Idaho, TM stands for transverse, and it's Mercator, meters. It all looks great and stuff, so what's going on? Well, let's just remove this since we don't need that anymore. In GIS, whatever layer you add in first, this map2, which is called the data frame, is going to take on those coordinate systems, or coordinate system, I should say. So if I go to properties, we can see it's still in NAD 83. So that's why it is not working right. That's why it looked kind of the same. So we want to use the coordinate system that we just selected. And so we can go and figure, we can do it two ways. We can go to our layers that we have, because these are going to show all the layers that are in our content pane. Right now we only have this one layer, Idaho tracks, and so we want to select this. Or another way you could have done is you could have gone back to projected coordinate systems and found it again, but it's easier just to go to your layers, select on that, say OK, and bam, it looks correct. So that's the first part we got done. Now the next thing we want to do is we want to take our data, and again, I saved it as a CSV file. You didn't have to save it as a CSV file. You could save it as Excel. It would just look a little different. When you clicked on it, it would say, well, what sheet do you want to add? But here, we put it in here. So let's open this up. Scroll down a little bit here. Notice we have 298 records in there. So to join this data, this standalone table, to the Idaho tracks, you need a common field. It's called a common key. This header can be named anything. They can be different in each file. It doesn't matter. That does not matter what it's called. What matters is the data down in here. So then if we open up this, so now what we need to do is find out, well, what variable are similar in this that is similar in this. And it turns out it's this row here, or this column here. Notice that the header is different name, doesn't matter, but this data is all the same. And you also notice there's 298 tracts in Idaho, and there's 298. If you were to join different year data to different census tracts, for example, after the 2020 census, they redid these census tracts, so there's more of them now because the population is growing. There's roughly 4,000, 5,000 people per census tract, and since the population is growing, they make more census tracts. So if I were to join 2010, 2019 data, it would be different because there wouldn't be enough census tracts, so you get a bunch of values that don't correspond. So anyways, we got that. So now we know what field we can join on. So we can just close that. So if we go here, we go to join and relate, add a join, tracks. So for the shapefile tracks, we want to join on this one. For the table, this is the table we're using, and it just kind of looks for the same variable that's kind of similar. So we want to select GeoID. You can validate it if you want. Click OK. And now, if we open up the attribute table, when you do a join, it joins to the end of the either shapefile or feature class, whatever you're using, data. And here we are, boom. There is all our great data. Now, joins are temporary. So what you would want to do is then export this out and call it, I don't know, something informative. Idaho percent 25 and over, bachelor's, something like that. You want to export it out. I'm not going to do that. So the next thing you want to do is symbolize this. So you can go here, symbology. It's going to open up the symbology team. So we want to do a graduated color. And this is where I was talking about if your data is not numeric, you won't be able to symbolize that. So here we got to figure out what we want to do. Notice how there's a lot of variables in that attribute table that don't appear here because all those values are text or string, not numeric. Here's our percent 25 and over. And there it is. So exciting stuff, right? And then we can scroll in and you save that and we can have Ada County. I think this is that Blaine County maybe? Is that Blaine County? So anyways, so now you can see percent 25 and over. Kind of makes sense that Ada County has a lot of people 25 and over with a bachelor's degree since it's the capital. So there's generally speaking more people with college degrees doing work in there. Same with up in Moscow. I think that's Blaine County. Sun Valley, a lot of people with a lot of money. Generally speaking, the more money you have, probably more college education you have, and so forth. So, long story short, there is your map and how you do that.